Is there the possibility for, if somebody badly programs something, too many interrupts to make things not work very well?
There's always that possibility, yes.
This might be a terrible example, but knowing me, when the knock at the door comes, it's usually somebody like Amazon trying to deliver a parcel. And by the time I get there, he's gone off and he's... I don't know if that works as a metaphor at all.
Yeah, so it's certainly possible to badly program an interrupt. So the idea is to get in and get out. So if you were to... so using the serial example, if you were expecting 64 bytes of serial data in, and you knew you needed to store 64 bytes and then process it, you received the 64th byte in your interrupt handler, and then you went off and also processed those 64 bytes in your interrupt, and that might be quite involved processing, it might be quite slow if you were writing to a SD card or something like that, any slow operation. Say if more serial bytes were to start coming in, you wouldn't be buffering those because you're already in the interrupt. So
you can't interrupt an interruption.
But no, some processors will allow for something called re-entrant interrupts, where you can interrupt an interrupt. But generally, you don't want to go down that road because it leads to nasty things like race conditions and all sorts of stuff happening.
So basically, use an interrupt where you need one, not just for everything.
Yeah, I mean they're fantastic things, and I think use them where you can, but keep them short, keep them simple, and definitely don't have anything that has the potential to delay processing for a long time. So if you're receiving serial data, just get the byte out of the hardware somewhere safe, and that's it. And leave your application to work out, oh, I've got 64 bytes in there, I need to deal with them. And then that processing might get interrupted if you're doing that, but that doesn't matter because your application can take a few more processor cycles to do it, and it won't ever lose that information, whereas you might lose it if you were to process it all in the interrupt.
Is this something that most programmers will have to deal with, or is this something that's sometimes taken care of by libraries?
So it's almost if you're working, if you're doing desktop programming, web programming, you will most programmers once you get up to high levels almost never have to deal with interrupts directly. It's generally in the operating system. It's only when you go down to microcontrollers that you really have to know they exist and know what you're doing with them.
So this is people who are doing Internet of Things or hobbyists or makers. They're probably going to have to be dealing with these perhaps more than...
Yeah, definitely. And it can be a bit tricky because when you start learning, you're used to execution going sort of line by line, and then you learn about if statements and switches, and you can control program flow. But then you find out that the interrupts can make it jump to a completely different part of your program, and it can be a bit tricky. But they're really useful, and it can take an enormous amount of processing burden off your application and simplify quite a lot of things. Just by you're not constantly having to check what's going on. The hardware is there to support you and give you the means to detect these events.
Is this like having a little hardware butler who's going to take care of some things for you?
But yeah, exactly that. It's just constantly having a look out on all these different things. So in fact, here I brought up the data sheet for this microcontroller, and it has a list of all they're called interrupt vectors. It actually has a list of all the program addresses that the execution will jump to when that interrupt happens. So the top one is the reset address. So when you plug power in, that's an interrupt. It starts at the effectively interrupt. It starts off at program address 0, and then there's in total 26 different interrupts that it's possible that the hardware can respond to, and each of those you can write a small interrupt service routine if you need to respond to that event.
So do you just use one of those that's already sort of set up, and you just say, right, okay, let's use number 10 or whatever?
Yeah, so you write a normal function, just like any other function you would write, but so in Arduino you use you attach interrupt. You basically say, hey, this is a special function that I want to be called when the interrupt service routine fires. So the actual interrupt service routine is in the Arduino library. Shall I bring that up? I can try bringing that up. Okay, well, okay. So here's the actual place where in the Arduino library it says this special function is an interrupt service routine. And here's one first. So you've got int 0, int 1, and int 2, which correspond to, well, in this microcontroller, there's only int 0 and int 1. And this is a special instruction to the compiler to place that code at this program address. So that's what will execute when the interrupt runs, and then that interrupt in the Arduino library deals with making sure that your sketch function gets run.
So I'm going to go back to your analogy of the doorbell going, right? We're working away and all these interrupts, one might be the doorbell, one might be the phone ringing, one might be somebody knocking at the back door. Is that sort of fairly...
Yep.
And all of them would cause you to do different things, potentially. Pick up the phone, walk to the door, miss the Amazon delivery, etc. But you can decide what happens when some of those happen. Yeah,
so in the case of the Arduino library, it's each of those, essentially you have a different little butler, and you've told him whether you care about that event. So you might not care about the back doorbell. So you tell him just you ignore it. But you might care about the front door. So you say, hey, actually, I need to know about this. And that's what the attach instruction does. It says, I care about this thing and you need to tell me. The fact that there's all this extra complexity behind it actually makes the interrupt longer. So I'd say ideally you want to keep your interrupt short. Arduino have put this extra bit of processing in so that you don't have to care about the low-level programming, which makes the execution slightly longer. But like a lot of Arduino stuff, it also makes it simpler, and that's the idea of it.